In this video, we're starting section 2.3 on functions. So our goals are to define what a function is, to find the domain, codomain, and range of a function, determine when a function is injective and or surjective. So we'll talk about what those terms mean, and to define the floor and ceiling functions. It's a lot of terminology here, but we'll learn what all of this means. So in this video, we'll talk about functions, domain, codomain, and range. So let's get into some definitions. You've likely seen functions before, a bunch, in algebra class. So let's just recall the definition. A function from a set S to a set T, and the way this is written is using this notation. F represents my function. This S and T, they're both sets, and what the function does is it takes each element of S. The elements of S are the inputs, and for each of those inputs, it assigns them to exactly one element of T, and those are the outputs. So each input that I can plug in has exactly one output. That's likely something that sounds familiar from like algebra class. So this set S of inputs, this is called the domain, and the set T is what's called the codomain, which may be a term that you haven't heard before. So the domain is all of the inputs, and the codomain is all of the possible outputs. And it'll be more clear what I mean by this word possible in just a second. There's another term that you've likely heard in algebra class, which is range. So what's range? The range, the way I read this is the set of elements lowercase t in my set capital T. The vertical line means such that, so the set of elements in capital T, such that I need there to be an input, S, that gets me T as an output. So the way I say that there is an input is I say there exists a lowercase s. That's an element of capital S, because capital S is my domain, such that when I plug lowercase s in, I get T out as my output. So, okay, so the range is all of the achieved outputs. They're all the outputs we actually get. So there might be outputs that we don't actually reach. So the codomain is used to refer more broadly to all of the possible outputs. So let's draw a diagram of this to get a better visual sense of what the difference is. So I'm going to have an oval with the elements 1, 2, 3, and 4 in it. This is going to be my domain. This is going to be my domain right here. And then I'll have another oval that represents the codomain. And let's say that the codomain has, maybe it's got more elements. Maybe this is 4, and this is 6, and this is -3, and then I have 8, and then I have 0. Okay. And before I say which input goes to which output, let me just copy this, because I'll also give an example of something that's not a function. All right, so maybe for something that is a function, maybe the 1 gets mapped to the output 4. Maybe the 2 gets mapped to the output 6. And maybe 3 does as well. That can happen. Sometimes multiple inputs have the same output. And maybe the 4 gets mapped to the output 0. Okay, well, what's something that's not a function? So maybe in this one, 1 gets mapped to 4. And now I'll introduce the problem. What if 2 has multiple outputs? What if it has 6 as an output and 4? That's a problem. Regardless of what happens after that, like maybe 3 goes to 8 and 4 goes to 0, the fact that there is one input with multiple outputs, that cannot happen according to the definition of a function. Okay, so this is problematic. That makes this not a function. All right, so graphically, let me draw some axes here. So one set of axes, another set of axes. Something is not a function if there's an input like this that has multiple outputs. Graphically, what would happen is my function would not pass. If there's an input like this, maybe this is 5, that has multiple outputs, it's got multiple outputs, that means the graph doesn't pass this vertical line test. So this fails the vertical line test, which means it's not a function. Okay, so something that is a function needs to pass the vertical line test. So one example is maybe a graph like this. This one passes the vertical line test. Okay, so what's the difference between codomain and range though? Let's go back to this first diagram. The codomain consists of all of these outputs, even the ones that we didn't get actually as an output, like -3 or 8. We never actually hit those. The range, I'm going to shade in the range, consists of the ones we got, like 4 and 6 and 0. I'm going to shade those in. So the ones we actually got, I'm going to shade them in. This blue region, that is the range. The range is the ones we actually got. So there could be some outputs in the codomain, like a -3 and 8, that are not part of the range. All right, so we're ready for another definition of what's called the image. So if W is a subset of S, meaning it's a subset of this domain, the image, the way I read this is, it's the set of F of W, where lowercase w is an element of capital W. And what that means is, when I input the elements of my set into the function, what are the outputs I get? So the easiest way to explain this is with an example. So let's say that in the first diagram here, W is the set that has 1, 2, and 3 in it. So these 3 inputs in it. F of W, the image, consists of, well, what are the outputs of those 3 inputs? Well, the output of those 3 are just, it was 4 and 6. 4 and 6. And that's it. That's what image means. Okay, so I want to end this video with an example where we determine which of the following things are functions, specify the domain, codomain, and range of anything that is a function. So part A says F is this rule where the inputs are within this thing, which is reals greater than or equal to 0, and the outputs are within the same thing, non-negative reals. And it's defined by this formula, f of x equals square root of x. So, we might recall, for example, what the graph of square root of x looks like. The graph of square root of x kind of starts at the origin, and then it curves upwards like this. So the fact that the inputs are the non-negative reals, the inputs are all non-negative reals, means we are looking at the entire graph here, rather than just like part of the graph. Okay, so if the inputs were defined differently, then maybe I'd just be looking at part of the graph. But here, we're not. It's the whole graph. And if I look at this graph, clearly there's no input that has multiple outputs. This thing is going to pass, it's going to pass the vertical line test. So it is a function. It is a function. The other thing that's important for it to be a function is, well, the domain, codomain are specified. So the domain is specified here. It's my reals greater than or equal to 0. Same thing for codomain. The codomain is specified here, which is also reals greater than or equal to 0. And the range, well, one way I could determine the range is, I have the graph, so I can use the graph. The range is all of the outputs we actually got. But since the graph, all the outputs I get they start at 0 and then they get bigger and bigger and bigger, the range happens to be the same for this example. The reals greater than or equal to 0. Okay, so what about in B? In B, I have a similarly defined formula for G, square root of x, but now this output set is different. So all of these values are going to be the same. It passes the vertical line test, so it's going to be a function. Let's copy that down below. But the one thing that's different is this output set. This output set. So as a result, that's going to change my codomain. That is going to change the codomain to just be, in this case, it's R. It's all reals. So in part B, the codomain consists of all reals. So there's some things in the codomain that don't happen to be in the range. There's some possible outputs that we don't actually achieve. We never actually hit. Okay, so one final example. What if I have this, but there's no input set or output set specified? Well, back in algebra and calculus, when we see a formula like this one, it's assumed that there is a domain and that the domain happens to be the largest possible one, which for this formula, the largest possible domain would just be all the non-negative reals. But now in discrete math, the domain and the codomain have to be specified alongside a formula for it to actually be a function. And there's no specified domain and codomain here, so as a result, for our purposes, this is not a function. So going forward, anytime I see a formula for it to be a function, this domain and codomain, they have to be specified.